Hello guys, I am Radesh Chandaluru, a coordinator of Programming Club IIT Madras. So we have successfully conducted the first contest of competitive coding conclave summer camp, and I want to congratulate all the winners, and I hope that everyone will enthusiastically participate in all the other events of this camp. There will be one more contest as well, and the problem sets. We hope you do them enthusiastically as well. So we are making this editorial to explain the 8 problems which are part of the contest. In case you did not solve some of them, you can check this out. We also made a text editorial. Uh, I'll be explaining the text editorial, and we can also submit some problems, and I'll also code some. So yeah, let's get started. So let's say first problem. First problem is monkeys of IITM. This is a pretty straightforward problem. For every odd second, the monkey goes up by A meters, and at every even second, it comes down by B meters. So if n is even, then the monkey will be at height A minus B into n by 2 after n seconds. If n is odd, there's a slight change because when n is odd, it will also go up by an extra A meters. So in that case, we will change the code a little bit. Also, if you look at the code here, you might be confused because in both of them we have written n by 2 into a minus b. But the reason we wrote that is because let's say n equal to 5 when n is odd. So when you do 5 by 2, you'll get 2.5, and you'll be like, that's weird. Why are we multiplying by 2.5? But in the computer, 5 by 2 is evaluated to be 2. So we basically get n by 2 is the 2 here. So let's say when n equal to 5 odd, then 2 into a minus b plus a, that is the answer because it is going up by a meters 3 times and it's coming down by b meters twice. So that is what is happening here. So this is a pretty straightforward problem. I hope there is no problem in this. And in the code, you can ignore this part mostly. This part is basically just extra stuff and all. The main part is from here. Uh, Main part is this part. This is the main code here basically. Please check it out, and that was pretty easy. Let's move on. Second problem is traffic lights. So basically, we basically have to find the in this problem we basically have to find the lowest common multiple of a and b. Uh, in C++, there is a function for GCD, and we know that the GCD of two numbers times the lowest common multiple is equal to a into b. So we can say that the LCM is equal to a into b divided by GCD, and that it's basically done. We just have to write that. So here and count this. This is the GCD function. If you don't want to use the inbuilt function, you can also code it using Euclid's algorithm. We have explained that we explained that in our sessions. It's pretty straightforward. I don't really think you would require that. You can just do it like this because the GCD algorithm in C++ is pretty good. And let's check the next problem. This is the next problem, password trouble. So basically, IIT Madras is making a new server for its ICPC activities. It requires entering the correct password on another computers. He has been given special instruction to reinforce the alphabet used most times while entering the passcode. Rajesh is also a bit lazy. If a few alphabets have the same number of occurrences in the password, he will reinforce the first alphabet closest to A in terms of ASCII value. Find the alphabet he would reinforce in each of the n keyboards. So basically this is a basic frequency array question. You just find the frequencies of every letter in the string, and then you start checking from letter A to letter Z. So whichever then you store the maximum frequency, and then you again check from A to Z. Whatever is the first letter which has that maximum frequency, you output that. Okay, there might be several letters with the same maximum frequency, so that is why we are checking from the starting, because they said that if there are many such alphabets with same maximum frequency, we have to output the one closest to A. So this is also a pretty straightforward problem. Let's see. So this is how it was implemented. Defined n, take input n, string s, sin s, and then frequency array was made. And you might be confused what this is. Don't worry much about that. That is just a loop. That is just a for loop. It is just written using define. Don't worry much about that. That's just a for loop. And in the for loop, what did he do? He just found the frequencies. So this is written like this because si is the ith is the I plus what character, and then he did minus a. That basically will give the, let's say the I plus 1 character was a itself. So a minus a, that's 0. If it was b, it will be like b minus a. That will actually give 1, because actually characters are stored as 1 byte, in a computer. So it is able to do the subtraction, and it is able to understand it as an integer itself. So it works. Then char mx, int mx. So and then he basically took another for loop, and if this frequency is more than mx1, we'll say that mx1 equals fi. Mx1 is basically the max. What do I say? That is the maximum frequency thing. So and mx is the maximum frequencies character. So we store that, and observe that here what is happening. Here it is moving from A to Z, and it is storing the maximum frequency character. Only if some other character is there later which has more frequency, mx will change, right? So it will always have the first character with the highest frequency. It won't have the next character, right? And then we just output mx. Also a very easy problem. This is sum by 3. Basically in this question there is a number given, and we want to know if that number can be represented as the sum of distinct powers of 3. Okay, so this is a good question, I guess. For starting off, this is a good question. If you understand the logic, it becomes pretty simple it becomes pretty simple. So let me just explain. So this is a solution. If we have n written in base 3, each digit must be either 1 or 0. If digit 2 are present, we'd have to use 2 equal powers of 3 to create sum of n, which is not allowed. So all we have to do is convert n to base 3 and check if any digit 2 is present. Pretty simple. So let me just explain what that means. He basically means that let's take some examples and see. Here 4 is equal to 3 power 0 plus 3 power 1. So that is pretty simple. It can be represented. And what is the base 3 representation of 4? It is basically 1 0. I mean not 1 0. I mean the it's 1 1, not 1 0. My bad. And 9 is represented as 1 0 0. Okay, and 9 equal to 3 square. 13 is represented as 1 1 1, and it can be written and 820 it can be written also. And why can't 7 be represented as sum of distinct powers of 3? Let's check. So we have 7. Now 7 in base 3. What is it? So well, 9 6 6 3 9 6. So it is basically 2 2 1. I'll explain. So basically 2 into 3 square, I mean not 2 into 3 square, 2 into 3 plus 1 into 3 power 0, that is 7, right? So let me just write that 7 is equal to 3 plus 3 plus 3 power 0. Now, why can't we write this as a sum of distinct powers of 3? Observe that we can't use 3 square or any higher power, because if we use it then the sum will be more than 7. So we have to use smaller powers only. But observe that if we use 3, then we can't use it again, and only 3 power 0 is left. So you can't really write the sum as sum of distinct powers of 3. So thing is that when you write in base 3, every digit should be either 1 or 0, and if it is so, then we can write it as distinct powers of 3, as a sum of distinct powers of 3. So let me just explain how we do that. So how do we find the digits in base 3? So this is how we do it. To get the first digit, we will simply do 7 taken remainder when divided by 3, that is equal to 1 here. Then we divide 7 by 3. 7 by 3 is equal to 2. And I mean what the computer does basically, when we divide 7 by 3, it says 2 because it needs to give an integer answer. We do not care about the remainder part basically, so that's why it's like this. Now when 2 divided by 3, remainder is 2, so that means it can't be written as distinct powers of 3 sum. So let's see let's see why this works briefly. Let's say some x number is 3 power is a into 3 power n plus b into 3 power n minus 1 plus until some z into 3 power 0. Now what is happening in this operation is that when we take the remainder, when x is divided by 3, we get z, right? So we write z there simply, and then we divide z x by 3. When we divide x by 3, what does the computer give us? It gives us this, x divided by 3. The remainder goes away and we get a into 3 power n minus 2 n minus 1, sorry, plus b into 3 power n minus 2, so on until maybe some y into 3 power of 0 is x by 3. Now to get y, what do we do? To get y, what do we do? Let's call it x1, just so we don't have any confusions. Now we take this x1 by 3, whatever it is. Now we take the remainder when this is divided by 3. Let's say this is some So this is some num, so num percentage 3, that equals y here. So we keep on doing this basically, and we get all the digits. And if any one of these digit is 2, we are done. We cannot write the number in as a distinct, as a sum of distinct powers of 3, else we can. Let's just try coding this once. No. It's st namespace std name. First of all, intention while n minus 1. Basically, for all the test cases, we're doing this. Now we have some x sim x. Let me just check out. So x can be up to 10 power 5 basically. First of all, now we'll check every single digit while x is greater than 0. If x, take remainder when divided by 3, is greater than 1, then we could no, and we end this. We output no in that case. And then we can break this loop. If x is less than or equal to 1, then what do? Then basically we update x, because we want to move on to the next digits, right? So then we will just say x equal to x by 3, and then we will move on. We will move on until we check all the digits of x. Okay. So when x becomes 0, that means we've checked all the digits. Then we are done. This something is wrong. As expected, I have done some mistake. It's common to do mistakes. Let me check it out. Yes, I forgot to print no. I forgot to print yes. I mean, I forgot to print yes. Oh my god. So let's just put some flag here. Int flag is equal to 1. And if we're printing no, we'll just put the flag is equal to 0. And once it comes out of the loop, it will be coming out of the loop. Uh, it will be coming out of the loop. So in case when it comes out of the loop, flag is 0, then we won't output yes. That's basically it. Accept. I made a dumb error. So instead of n1, I wrote n in all these places, and they should be or, by the way, because only when both are true If either of them is true, then we should still increase the frequency. Only if both of them are zero, then we should not do it. So let's move on to the next problem now. Help Oppenheimer. So Oppenheimer has an electric detonator which only works if it's charged at least X kilowatts. He was busy watching the Barbie movie, so he forgot to charge his detonator. Luckily, he finds a store that has N power banks where ith power bank can provide AI kilowatts. The cost of buying the power bank is I into AI. However, due to limited space, he carries exactly two power banks. Oppenheimer is very stingy and wants to spend as little money as possible on these power banks. He sacrificed his brain to make the atomic bomb, so now he needs your help to find the minimum cost to charge the detonator to required capacity. Print this cost. If it is not possible to charge the detonator to the required capacity, print minus 1. So the first line is the number of test cases. The next line contains X and N. X is the required charge and N is the number of power banks. Then we have the AIs of each power bank. So this problem is basically brute force and we can easily do it. Since n is less than or equal to 100, we can simply check all possible pairs I and j and take the minimum cost among all pairs where ai plus aj is greater than x. So let's see the solution. So int xn, take the input, then we make the array. Then this is the for loop. We are taking the input of all ais. Now we just write int cost is equal to int max. Second. So we want to find the minimum cost. So initially we say that cost is very high. We take the largest value in integers. Then this is a flag. So now we just go through all the possible cases of I and j. So if ai plus aj is greater than equal to x, then this is the cost for that. If this cost is less than cost, like if this cost is less than the minimum cost before this, then we will change cost and we will say flag equal to 1. Why are we doing this? Because we can come here only if ai plus aj is greater than equal to x. So that means that if there is at least one ai plus aj which is greater than equal to x, then flag is equal to 1. So at the end, if we did not come to this position at all, even once, that means that there is no ai plus aj which is greater than equal to x. So then we'll just print minus 1. Else we'll print that minimum cost which we got. That's it. Simple. Let's move on to the last problem now. So in the ancient land of Numeria, there exists a mystical sequence sorting technique known as the mystic sequence sort, involving a special operation f. F of a of b is defined as given below. If they have different signs, return their sum. If they have the same sign, subtract the largest number from the smaller number and return the result, where a is a smaller number if a is less than or equal to b. Now, what does that basically mean? This basically means the absolute difference. Oh no, okay. I mean, let's talk about it later. And an array is considered a mystic sequence sorted An array is considered mystic sequence sorted if the absolute value of f of consecutive elements of the array is non-decreasing. So what are they saying? They are saying the absolute value of these differences, this some type of differences that f is non-decreasing. And what would be the absolute value of f? The absolute value of f would basically be the absolute difference of a and b. And why is that so? Let's see. Let's say that a and b have different signs. Let's say that a is maybe 7 and b is minus 2. What is the sum? The sum is 5. Now let's say a is minus 7 and b is 2. What is the sum? Sum is minus 5. Now let's say they have same sum. A is equal to 7, b is equal to 2. Now what do we do? Subtract the larger number from the smaller number. So here we have 2 minus 7 minus 5. Observe that we're always getting the absolute difference between the absolute values. So that basically means mod of a minus mod of b. We have to write all these elements into such a sequence such that these values are always increasing. Now how would we do that? Interesting. So first of all, the thing is, we do not care about the sign of a and b. That is the first thing. Now how can we get a sequence such that this value is always increasing? Let's see that. And we do not care about the sign initially, so let's just always write the integers as positive integers. And also let us sort them first. Let's say we sort them to be 1 3 1 2 3 7 8. What is the largest difference between any two numbers here? 8 minus 1, that's 7. That's the largest difference, right? So let us think. How can we and what is the smallest difference? Well, the smallest difference is 1 and 2. Let's not think about that much. Let's write 8 in the end, and then let's write 1. So there's the largest difference and we're writing it near the end. That's good. uh, then let's write 7 here. What happens then? The difference does decrease, because why does it decrease? Because 7 is less than 8, right? Now after 7, let us write 2. Now 7 minus 2, the absolute difference is 5. This absolute difference is less than the absolute difference of 7 and 1, right? So it is still following the order. And why is it following the order? That's because 2 is greater than 1. Now we can write 3. So what am I doing basically here? What is the pattern that I'm following? What is the pattern? I am moving backwards from here, and I'm moving backwards from here, and I'm outputting and I'm writing the numbers. So how did we write it? We wrote it like this. We wrote 8 at the end, then we wrote 1, then we wrote 7, then we wrote 2, then we wrote 3. So now we have to code this. Let us see the solution. So first of all, uh, we have taken the input for n, and then we have taken the input for the array. So after that, we have sorted all the array elements in decreasing order such that uh, we take the absolute differences. I mean, we take the absolute values into reference and not the uh, values with signs. As you can see, this is an operator. So this operator is used for the sorting. it will sort it such that in the end the array will be sorted such that the absolute values are decreasing. So basically, how do we have the values here? So in the sorted array, we are having values. We will be having values like this actually. Now we have to basically move from here. Move from here. So 8, 1, and then 7, and then 2, and then 3. Right. So we can see what he did. We can see what's in the solution. We have defined something, an array to output. This is the output array. Okay. Now we will be moving from the back. We will be moving from the back of the out array. So for I equal to 0 until this I. So as I said, we will write in the first loop what's happening. Out of n minus 1 is equal to array of 0. That is basically we are setting the last element to the largest possible number. Then we are setting the second last element of the output array to be the smallest, because array of this basically becomes uh, r of n minus 1. That is the smallest element because we have sorted it in decreasing order. So that's what happens here. And after this, we basically have the whole array which we have to output. So we just output, and that is basically done. So that is the editorial for the problems of competitive coding conclave contest 1. So thank you. I hope you understood the solutions, and yes, please subscribe and like our channel. So yeah, see you next time. Okay, now let's move on to the last 4 problems. So you can read this problem. I will tell you the essence of what we have to do. So in each of the inputs, there are multiple test cases. In this input, there are 3 test cases. And what we have to do is, for this sequence of numbers, we have to remove the minimum of the given integers such that the remaining, in the remaining, there is no such 3 consecutive integers. Let's say the integers are x, y, z, and x greater than equal to y and greater than equal to z. There should be no such three integers consecutively. And basically, so there should be no such consecutive 3 integers like that. What is the minimum number of integers we should remove from here such that that happens? Now in the first one, we only need to remove only one. Maybe we can remove, maybe you can remove 4, or maybe you can remove 7, or maybe 2. If we remove any one of those, it would be satisfied. For this one, we don't need to remove anything, and for this one, we can remove 2 or 3 or 1, any of them. So how do we solve this? So for this problem, let's say we have a sequence. Let's say the sequence is 4, 6, 7, 2, 2, 3. Now let a subarray L to R be decreasing if it satisfies AI less than greater than equal to AI plus 1. So the maximum length of such an array in the final after removing all the books is 2, because if it were 3, then we would have 3 such consecutive integers, right? So the idea here is to separate the initial array into subarrays of this type. What I mean is, we should separate this into decreasing subarrays. So here, what would that be? Here it would be 4, that is one subarray, 6, that is one subarray, next subarray is 7, 2, 2, and third subarray is 3. And every subarray should have maximum of 2 numbers. So if a subarray has one element or 2 elements, you don't need to remove anything. But if a subarray has more than 2 elements, then you have to remove some elements to get it down to 2. You don't need to get it down to 1 or 0. You just need to remove some elements such that it comes down to 2. That's it. So that is the logic here. So how would we code that? Now see that for any decreasing subarray, which has more than uh, 2 elements, observe that for the middle elements here, let's say for 2, we have 2 is less than equal to 7 and 2 is greater than equal to 2 on the right side, right? Let's add one more element here actually, just to make it better. Let's add 1. So we get one more element here, 1. So observe that in these subarrays in 4, 6 and 3, 1, there is no such element such that it's following that criteria. Okay, because 3 is greater than 2, 3 is greater than 1, but it's not satisfying the criteria that was satisfied for this number, this 2. So observe that we only need to remove those elements which satisfy that. And what is that relation? We should remove those elements which have ai minus 1 greater than equal to ai and ai greater than equal to ai plus 1. If we remove all the elements which have this, then that will be the minimum number. So we can do that. Let's try that out. I'll take the input for every one of these. Now observe that for the end elements, we don't have to check because they won't have any element before for the first element and after for the last element. So we only have to check for the elements in between. So this is my solution. Uh, there is a bit different solution given in the text editorial. This seemed a bit easier for me, so I'm doing this. Yeah, it might be the same actually, but this is much easier. Wrong, of course. I probably made some mistake. First line differ. Expected one. See, I always make a mistake. Now what's the problem? It's wrong again. Yeah, it happens. I do I do a lot wrong. Yeah, it's gonna work now. Cool. Let's move on to the next problem. Ring quest. So this is a ring quest. Basically, there is a n into n grid, and there is a guy at one position. The position is given. Now the question is, can you find 9 different positions on that grid such that all 9 positions are the same exact uh, have the same exact distance from Frodo, where distance is defined as uh, the number of moves it takes you to get to this Frodo. Frodo is the guy. So, and by moves, I just mean moving left, right, or up, down. So, distance, that is minimum distance. So, you can just find that distance by using coordinates. It's pretty easy. So, how do we do this? So, basically, observe that for any grid which is 20 by 20 or greater, uh, we will always output yes because we can find. No, just think about it. Place the guy at any position. You can always find 9 places which are equidistant from the guy, right? Now, for 20 by 20 or greater, we'll just output yes. For smaller things, we'll have to check. How do we check? Now, we can just use brute force for smaller things. It should work. Note that in the editorial, there is a slightly different solution. I like this solution a bit better, so I will do this one. The first integer is n, next integers are x and y. So x comma y is the position of this guy, and the bottom left cell is 1 comma 1, and it moves forward. When we go right and up, it moves the y direction upward. So this is the position of that guy. Now if so if n is greater than equal to 20, output yes, and continue to the next loop. Now what do we do for 19? I'm just gonna be going with the brute force approach, kind of. There is a bit more elegant solution, I guess, in the blog. I'll be going with this. I'll just be checking for every distance uh, how many blocks are there. So for n equal to 19, the maximum distance is for n equal to 19, the maximum distance is 36. For n equal to 18, maximum distance is 34, etc. So we'll make a frequency array of all the distances, and for each distance we'll find the frequency of blocks. If there's any distance which has frequency greater than equal to 9, then we are done. No. So after this, the frequency array has been made. The absolute value of x1 minus x plus absolute value of y1 minus 5, that is the distance. So we are incrementing the frequency of the distance. So after this, we'll have the frequency array. Now we just have to check if there is any distance. We have to do -1 also, I forgot, because it's an array. We can do it a bit different. Int flag equal to 0, flag to 1. So basically, if I find any frequency greater than equal to 9, I'll put flag is equal to 1. And when I come out of the loop, I'll check if flag is equal to 1. Count yes, else, see out. This should work. Compilation error. What is the compilation error? X1 was not declared in this. My god, forgot a semicolon here. Let's see if it works. Runtime error. Let me check. Also note that there is no time error here because we're only doing the nested loop for n less than equal to 19. So it's fine. What's the error? Runtime error. Hmm. Yeah, the maximum distance is right. There is runtime error because distance can equal 0 as well. We should just say if x1 not equal to x and y1 not equal to y. That is the error because when x1 equals x and y1 equals y, then we'll get this to be -1. This should work. Let's hope it works. Again, runtime error.